Hello students, hope you are all doing well back home. Today we're gonna start the part 2 of networking that includes our topologies and the networking devices. Before switching to these topics, I'll just give a quick recap of the topics that we have touched in our previous video. And those topics are networking, need, advantages, IP address format, classes, what IP address is, DNS, and the types of networks. So now we're gonna switch to topology and we'll discuss the various types of topologies. First, we'll be discussing what network topology is. Network topology is defined as a way the network is laid out physically. By physically, I mean how the components are interconnected to each other. Or I can also define topology as the geometrical representation of the relationship of the links and the linking devices. By linking devices, here I mean the nodes. Again, I'll repeat the definition. Topology can also be defined as the relationship of the links and the linking devices to each other. Now, the topology can either be physical topology or the logical topology. Physical topology refers to the configuration of the cables, computers, and other peripherals, whereas logical topology is concerned as how the information flows or how the information passes between the workstations. Fine. So the various type of topologies are the bus topology, star topology, mesh topology, and tree topology. We'll be discussing first of all the bus topology, its advantages, disadvantages. Likewise, we'll be discussing advantages and disadvantages of all the topologies that are mentioned over here, starting with bus topology. In bus topology, all the nodes, by nodes I mean the devices, are connected to a single cable called as the backbone. These nodes are connected to the cable by drop line and a tap. First of all, I'll make you understand what drop line is, what tap is, and then you will check it diagrammatically. Drop line connects a node with a cable. That is, a drop line is a wire that connects a node with the cable. On the other hand, tap acts as a connector that slices into the main cable. On the both ends of the channel, there is a terminator. Terminator just absorbs the signals so that they do not reflect down the cable. A device can send a message that is seen by all the devices connected to the cable, but this message can be processed by only the recipient device. Now I'll be showing you what drop line and what tap is diagrammatically. Going to the advantages of bus topology, the first advantage is that it is quite easy to install, as it's easy to connect a computer to a linear bus. It requires less cable length than star topology. On the other hand, it is cheaper than star topology or mesh topology. This is because of the wiring cost required for star and mesh topology is much higher as compared to bus topology. It's mostly used in LAN networks. There are many more advantages, but these were the basic advantages of bus topology. Next, we will be discussing about the disadvantages of bus topology. First, difficult to add new device. Adding a new device requires replacement or modification of the backbone. Next is the fault in bus cable. If there is a fault anywhere in the bus cable, the entire data transmission will stop. Next is if there's a node failure, that is, even if one node goes down, the entire network gets affected. The next is, as I earlier said, there's a limit on number of taps a bus can support and on the distance between those taps. So, more the number of nodes connected to the cable, less will be the transmission speed. If you want to boost up your transmission speed, the number of nodes connected to your cable must be less. Then is terminators are required on both the ends of the backbone. That is a necessity. You need to have terminators at the end of the backbone. Then is the star topology, the next topology. In star topology, all the devices are connected to a central controller called as a hub. These devices are not directly linked with one another, but they are actually connected to a hub that acts as an exchanger. Entire data transmission between the nodes takes place via hub. If one device wants to send data to some other device, it has to send data to the hub, which then relays the data to the connected device. That is, the entire dependency of data transmission is on hub. The nodes are connected to the hub either via twisted wire cable, coaxial cable, or fiber optics cable. So kids, this is how the star topology looks. Now, advantages of star topology. First is it's easy to install and reconfigure. Next is it's easy to detect faults and remove paths, as failure of one node does not affect the other nodes. Only that link remains affected and other links remains active. It's quite easy to extend the network without disturbing the entire network, as you can easily add a node without in the entire system. Disadvantages of star topology. First is there's too much dependency on hub. That is, if hub goes down, the whole system is dead. Next is the number of nodes that can be added depends completely upon the capacity of a hub. If hub has the capacity to hold 4 nodes, you can't extend its capacity to 8 nodes or 10 nodes. You will have to replace the entire hub. Next is it's quite expensive in bus topology due to the wiring and cabling required for star topology. Mesh topology uses point-to-point connection. That is, there's a dedicated link between the devices it connects. Each node has multiple links to more than one node to provide an alternate route. That is, if you want to reach this PC, you can take multiple routes to reach this particular PC. Even if one route is busy, you can opt for other routes in order to transmit your data to the particular PC. Advantages of mesh topology. First is fault isolation and fault identification is easy. Next is there's an advantage of security and privacy. That is when message travels along a dedicated link. Only the intended recipient can see that message. Mesh topology is robust. That is, if one link becomes unusable, it does not incapacitate the entire system. These were some of the advantages of mesh topology. Then discussing about the disadvantages. The main disadvantage is that it is costly than any other network topology because of the wiring cost. Setup and maintenance of this topology is quite difficult. This is other a major disadvantage of the mesh topology. The next topology we'll be going to discuss is the tree topology, that is also known as the expanded star topology. Tree topology actually combines the characteristics of the bus and the star topology. That is, it consists of a group of star configured nodes connected to a bus backbone. Just try to understand that there are a number of star configured workstations that are connected to a main cable called as backbone. So this means tree topology is a combination of star and bus topology. Tree topology allows for the expansion of the existing systems and enable to configure a network to meet the required needs. Discussing about the advantages of first advantage is the point-to-point wiring of individual segment. Then is you can easily identify the fault, where the fault lies, in which node the fault lies, or in which segment the fault lies. So there's easy identification of fault. On the other hand, if one node goes down or if one node gets damaged, it won't affect the system, it won't affect our network. Other nodes of the network will function normally. So these were some of the advantages of tree topology. Talking about the disadvantages, if the backbone line, that is if the backbone cable breaks, the entire system will go down as there is high dependency on the backbone cable. Next is it's quite difficult to configure and wire tree topology as compared to other topologies. There are a lot of other disadvantages of tree topology, but these were the major and basic disadvantages of tree topology. Now we'll be discussing a major topic, that is network devices that are needed for data processing and communication within the networks or outside the networks. For example, within a LAN or between LANs, between MANs. So the networking devices that will be covered are hub, switch, repeater, gateway, router, and modem. A hub is a connecting device with many ports that allows some point merge into a single network. It's used to connect multiple twisted pair or fiber optic devices together and make them act as a single network. It's the simplest device that cannot filter data. Data packets are sent to all the connected computers, and the device has to make a decision if it needs the packet or not. As a result, there is no privacy as the message is sent to all the computers. And on the other hand, it also slows down the network overall. This was about hub. A switch is a device that provides a central connection point for cables from workstations, servers, and peripherals. It's often used in star topology and tree topology. It's highly secure as compared to hub because switches build a port map of all the IP addresses which respond to each port. And the message is sent to a particular IP address port. As a result, the message is not broadcasted to all the devices that are connected to the switch. As a result, it makes it more secure as compared to hub. And in present scenario, switches are replacing hub, but still you can see switch hubs in the older installations. A repeater connects two segments in your network cable. We know signals carry information within a network, but signals can travel only a fixed distance before attenuation endangers the integrity of the data. A repeater receives a signal, and before it becomes too weak, it regenerates the original bit pattern and then resends the refreshed signal. A repeater does not amplify a signal, it regenerates a signal. Thus, it is also known as a regenerator and not an amplifier. It's important to note that a repeater does not actually connect two LANs, it connects two segments of the same LAN. It's not a device that connects two LANs of different protocol. A gateway. A gateway is a network point that acts as an entrance to another network. It's a device that provides communication to a remote network or to an autonomous system that is out of bound of the host network nodes. It acts as an entry and exit point of the network. All the data routed inwards or outwards must pass through and communicate with gateway in order to use the routing paths. Generally, a router is configured to work as a gateway device in the computer networks. Or gateway is often associated with both router and switches, but how? See, router knows where to direct a given packet of data that arrives at the gateway. And on the other hand, switch, it furnishes that actual path in and out of the gateway for the given packet. So in this way, the gateway are associated with the router and switches. A router is a device or a software in a computer that determines the next network point to which a packet should be forwarded towards its destination. Router is connected to at least two networks that decides which way the packet is to be sent based on its current understanding. Router maintains a routing table, a table available with all the available routes and their conditions. And router uses this information along with some algorithm to determine the best route for the given path. That is, it selects the best path to route the message based on the destination address. Routers are the network gateways as they move network packets from one network to another network, and many can convert from one network protocol to another network protocol as necessary. The word modem consists of mo and dom. Mo is modulator that converts the digital to analog signals, and demodulator converts the analog signal to digital signal. Modem are connected both at the receiving end and the sending end. It's an electronic device that converts a computer's digital signal into specific analog signal that travels over the cable television lines. And at the destination, the receiving modem demodulates these frequencies, these analog signals back into the digital data. Computers use this modem to communicate with one another over the network. If we'll talk about the transmission speed of modem, it is about 33,600 bps, or you can even get higher speed than this. Then talking about the types of the modem, there are two types of modem. One is the broadband modem and other is the dial-up modem. Broadband modem connects to DSL, that is digital subscriber line, or a cable, and provide high-speed internet access. The modem is usually connected to a cable and then connected to computer through Ethernet cable and network adapter. Dial-up modem connects to internet using telephone lines, usually has much slower speed than broadband modem. So if we talk in terms of speed, we should switch to broadband rather than dial-up, because it provides high speed as compared to dial-up. This was all about modem. So now in part 3 of networking, we'll be discussing about internet, its facilities, and the advantages of internet. This was all for today. Thank you.